Funny. Scoot up. Okay, you're good. Oh wait, scoot up just a little bit more. Okay. Now you're gonna have to scoot back just sometimes. All right. Hey y'all.
Hey.
Today's objective is exponential functions.
All right. Our equation for exponential functions, we're going to talk about it later, is y equals a times r raised to the x power.
And a is your starting amount, your initial amount. We've been talking about what your initial amount is. And r is your rate of change, basically that common ratio that we have been discussing when we're talking about exponential functions in class.
All right, so example 1, we have a bacteria that grows in your mouth at a rate of 4 every hour. Suppose you start with 1 bacterium in your mouth. We are going to figure out how many bacteria we're going to have after each hour.
And we're used to having problems like this and filling out a table. So the first thing we're going to do is we're going to complete the table over here for the number of hours. So at 0 hours, the initial amount when we start is 1, because that's what the problem told us. You start with 1. And it grows at a rate of 4 every hour. So because we're talking about exponential functions, we know we're talking about a ratio. So that means it's going to be times 4 every hour, multiplying by 4.
So from 0 to 1, if we multiply 1 times 4, then in hour 1, we're going to have 4 bacterium in our mouth. Then 4 times 4 would be 16. And 16 times 4?
60.
I don't know. Check our calculator.
64.
All right, 64. And 64 times 4 would be 256.
1,024.
See, calculators are good. All right, so this is the amount of bacterium we're going to have in our mouth after only 5 hours, 1,024. So the question is it linear or exponential? Well, because we multiply by 4 every time, then it's going to be what, Ms. Hantlon?
It's going to be exponential, which means we're going to have a curve. It's not going to be a linear graph, it's going to have a curve.
And we already talked about our initial amount. Our initial amount is 1.
And the common ratio, that means how much that rate of change, that growth rate, and in this problem, it's growing, the common ratio is 4. So we're going to answer some questions about that information. You still have your table in front of you, and so we will sometimes look back at our table, and Ms. Barnes, I think, is going to write the sequence down for us. So number 4, use the information to predict how many bacterium there will be in 10 hours. The table only went up to hour 5, and we've been practicing this in class, and so for right now, we're going to use our calculator, and we're going to keep multiplying by 4 until we get to 10 hours. So we started with 1, and then we did times 4. That was 1 hour, and 2 hours was 16, 64, 256, and then 1,024. So this was 5 hours. 6 hours, I pressed it again, 7 hours, 8 hours, 9 hours, and 10 hours. Whoa, that's a large number of bacteria in our mouth. It is 1 billion. 1 million. Sorry, 1,048,576. $1,048,576. That's how many bacteria are in 10 hours.
Yuck mouth. So now we're going to write a now-next rule. We talked about now-next rules in our linear equations. You know it's always next equals now, but the way we are doing our rate of change has changed because instead of adding every time as we did in our linear unit, we're multiplying every time by 4. And then you remember you always have to include your starting amount. So we started at 1. So So this is your recursive function. Now you can only use this to find the previous function, like Ms. Cantler did in the calculator. You have to keep hitting enter till you get to the 10th term. So that's when we use now next, and remember that's called recursive.
So number 6 says write the explicit form of the exponential function. Ms. Barnes just showed you how to write a recursive, a next equals now. So now we're going to show you in this form, y equals a times r to the x power. A is your starting amount.
And as we talked about in the first slide, r is going to be your common ratio. What number are you multiplying by every time? That's your rate of change. X is your independent variable, and y is your dependent variable. So remember, these are coordinates. These are the numbers we can put in our input and our output.
So for example, in the table we looked at, we talked like it was 1, 4. That was one of the points. That was one of the coordinates. That means in 1 hour you have 4 bacteria. If the point was, 364. That means in 3 hours you have 64. So the xy, the independent variable is the number of hours, and then the dependent variable is the number of bacteria
For this particular problem.
And so we're going to actually write an equation, right? On this paper.
Okay.
Because I think the next one's
Yeah.
So y equals a is your initial amount. So in this, the initial amount is 1 times the r, which is 4, to the x power.
So that would be your explicit equation. 1 times 4 to the x power. Alright, so now we've kind of altered the example, and we're going to do another one with you. Suppose instead of starting with 1 bacteria, you start with 50. Start with 50 bacteria in your mouth. Alright, so we're going to first write the now next equation. So nothing has changed about our common ratio. It's still the same problem. We're just starting with a different amount. So now equals next times 4. So this time we're starting at 50. Now to go from your now next to your explicit equation, it's really easy. Whatever you're multiplying is going to be your rate of change, or your common ratio, and whatever you write your starting at amount is going to be your starting amount. So y equals 50.
So y equals a times r to the x. So a is 50.
And r is 4 raised to the x power. Now these two things are your coordinates, so this is what you would input, and y is your output, or otherwise known as your independent and dependent variable.
And it's really nice once you get an equation, because this last question, how many bacteria will there be in 5 hours? Now before you had an equation, you would have to type that into your calculator and hit enter 5 times. But now that we have an equation, we can plug it in. So 5 hours, that is our independent variable. So we're going to put that into our x as the exponent. So when I type into my calculator, I'm going to do this first. 4 to the 5th power, and then times 50. And in 5 hours, there will be 51,200 bacteria. And I got that by putting it into the independent variable and then plugging into the equation.
Later on in class, this last slide, when we come back to class, we'll actually tell you how you can use this y equals equation in your calculator and look back and forth at your table. But if you don't have a graphing calculator, you'll do just like Ms. Hantler did. You'll take the input value, plug it in for x, and simply solve for your y value.
We'll practice more.